In this example, we're going to look at what to do when we are taking the derivative of a function that includes the variable as an exponent. So if you notice what I have here, I have y equals 8 to the power of x times x squared. Now you may be thinking the product rule, and that is a possibility. But even if we use the product rule, we have the issue of trying to take the derivative of an exponential function. And the issue with that is the variable is up high where we can't touch it. And so we need to bring that down. And this is where logarithmic differentiation comes in handy. And that word, logarithmic, means that we're going to use log properties to enable us to work with the function more effectively. Okay, so you may remember a few of your basic log rules. The one that is most helpful for us is that if we take the log of something being raised to a power, we can bring that out front and turn it into b times the natural log of a. So let's see what this looks like in practice. Okay. In this problem, it's okay for me to take the log of both sides, okay, as long as I do it to everything involved. So I can do the natural log of y is equal to the natural log of 8 to the power of x times x squared. Now here's where we're going to use a whole slew of log properties that are really going to help make this simpler. First of all, on the right side, I'm able to separate these two terms using one of the properties of logs that says if I'm taking the log of the product, I can separate that through addition. So it becomes the log of 8 to the power of x plus the log of x squared, natural log, I should say. Then from here, we can use that property that I mentioned before to bring the power down out front. So I have the natural log of y equals x times the natural log of 8 plus 2 times the natural log of x. Now, though it still may look a little bit complicated, we've got everything on a level playing field now, so that we're able to take the derivative much more easily using our implicit differentiation. So our next step will be to take the derivative of each piece as it comes, remembering that one of our big pieces we'll have to be able to do here is that the derivative of the natural log of x is equal to 1 over x, utilizing the chain rule as necessary. So now I'm going to take the derivative of this whole thing. The derivative of the natural log of y would be 1 over y, because it's 1 over whatever is inside parentheses here, times the derivative of the inside. Now again, with implicit differentiation, we have this function y that we don't know, so we always multiply by y prime, treating it as if it's a chain rule function. Now from there, we'll take the derivative over here. This next term is one of the ones that is just a bugger for people to really recognize what we're doing here. Now here's the big piece for understanding. In order for this to make sense, you need to understand that the natural log of 8 is a number. In fact, let me get my calculator out and tell you exactly what it is. So I just went into my calculator and I typed in the natural log of 8 and I got 2.079, so I'll round that to 2.08. That's what this thing right here is, a number, a constant that isn't changing. Okay, and if I had 2.08x, you would all be able to tell me the derivative is 2.08. So using that same logic, the derivative of x times the natural log of 8 is just the natural log of 8 because it's a constant times x. And so that's really the slope of a linear function, and the derivative of the derivative of a linear function is just the slope. Okay. Now moving on to our next term, we have 2 times the natural log of x. So remember the derivative of the natural log of x is 1 over x, and we'll keep that 2 along for the ride. So we're actually almost done because we're trying to find the derivative. So we're trying to isolate y prime and get it by itself. I can do that by multiplying both sides by y. So I have y prime is equal to the natural log of 8 plus 2 over x times y. Now, we know what y is, so we're not going to leave it looking like this. Going back up to the top, y is equal to 8 to the power of x times x squared. So our final answer would be 8 to the power of x times x squared times the natural log of 8 plus 2 over x. Noticing that all I did was replace the y that I had right here with what y is equal to from my original function.